A very good afternoon. Gayatri ma'am, am I audible? Yeah. A very good afternoon
Yes,
to
audible,
everybody.
ma'am.
Yes. Thank you, sir. Thank you. Very good afternoon to all the participants and the speaker. So today we have come to the 10th session of this 6-day FDP. We have with us Ms. Gayatri, who is a master's in geotechnical engineer. She has around 5 years of in-field experience, which includes all geotechnical investigations, ground model preparation, FEM simulation, and liquefaction and assessment of liquefaction potential. Earlier, she was associated with AECOM. Now, she is a geotechnical engineer in COVI India Private Limited. We welcome you, ma'am, on behalf of VELTech and Department of Civil Engineering. I welcome you for this session.
Yeah, thank you for the great introduction.
Yes.
Good afternoon, everyone. Myself, Gayatri. As she mentioned, I have 5 years of experience in geotechnical design field. I have worked in Indian and overseas projects, mainly in infrastructural projects. Today, I will take you through one of the projects that I have worked, and I hope everyone can get inspiration, and I would like more people in geotechnical engineering field. I hope it will be an inspiration for some of the people attending the session. Yeah, thank you.
Thank you. Thank you. The session is over to you, ma'am.
Yeah, yeah. So I'll try to share the screen. Entire screen. Is it okay? Can you see my screen?
Yes, visible. Yes.
Yeah.
No, you can
Oh,
close that hide actually.
yeah.
Yes.
Okay. So let's start. So today we are going to discuss about the challenges in selection of foundations. This is a case study of Colombo Port. So what are the topics I will be covering today? First of all, I will give you an overview of the project and what was the geotechnical scope, and how was the geology of the site, and what about the geotechnical investigation, field investigations and laboratory investigations, and derivation of the parameters for the design, and type of the what are the type of foundations available, and how we are selecting the uh, which foundation to go with. So, and the design of the foundation, and I have worked on different codes like BS, IS, IC, Euro codes, and all. So that we will be discussing today. And a typical pile design example also I will give you, and regarding lateral pile capacity and the conclusion. So now we will have an overview of the project. This what I have done was an expansion of the Colombo port. I have worked for the West Container Terminal. The scope was to develop the container berth and associated marine works. The geotechnical investigation was conducted on selected locations for the purpose of identification of the subsoil condition. And there were 15 boreholes. One was onshore, and 14 offshore boreholes were done. And the total length of the container terminal was 1,400 meter, out of which the container berth was of 600 meter, and the rest 800 meter was consisting of the long berthing structure along with the closing structures at either northern and southern sides. So on the right, you are seeing the number of boreholes, that location of the boreholes conducted. This is the land borehole. All these 14 boreholes are offshore boreholes. Now this is a video giving an idea of the Colombo port. What I have worked on is a part of it, but you will get an overall idea of Colombo port. So let's go through that. Yeah. So in one of the terminals I have worked, that is a waste container terminal. The location plan of this is the proposed location. Can you see the laser point? Hello.
Yeah,
Yes,
we can.
Yeah,
possible.
yeah,
Yes,
yeah, yeah.
possible
Okay,
to see.
okay, okay, okay. So this is the proposed location of the waste container terminal. This is situated within the Colombo Port South Harbour, and this is within the port limit of the Sri Lanka Ports Authority. As I told before, the one borehole in the land, it was conducted on the field land, and 40 number of boreholes are coming proposed along the container berth. Okay, now we will come to the geotechnical scope. So, initially, first of all, when we are starting a work, we will have a desk study. That is, what are the data available? What are the existing data available? We will have a study of that and understand how are the geological conditions and what are the previous designs. So we will have an overall idea of the area and geology and the geotechnical investigation report. So after the desk study, if we feel the number of boreholes conducted are less, we can we can propose a additional number of boreholes, and once that is conducted, we will receive the geotechnical investigation report, and this investigation report will contain all the summary of all the laboratory field data they have conducted, all the borehole location, everything. It is a detailed report of the investigation done. From the investigation report, we will prepare a geotechnical interpretative report, which is it will be a summary of the investigation done, and from the summary we will interpret some data and derive some parameters which is useful for the design. So there were two scopes. One was geotechnical design report, and another is slope stability report. So geotechnical design report contained the foundation design, which was a bore to pile design, and the slope stability for the berth and north and south bund revetments also were conducted. This slope stability will be conducted to protect the port from wave action. So we will go in detail with the pile design in coming slides. So now the geology of the site. So on the right side you can see an image. It's a, it is a depiction of this borehole investigation data. This is a longitudinal profile showing the soil layers, all the subsoil strata available. With that, we have made a profile. So on top, this yellow region, that is a silty clay or clay or silt. Both are the legend is used for both. And next will be fine to medium sand, and this is medium to coarse sand. Sand is mainly the main soil available there. And after that, there is a weathered rock available. Beyond that, we have hard strata. So the soil types available are clay, silt, or sand. The rock available is garnet biotite gneiss, which is a metamorphic form of this granite. And in this profile, almost on a average, soil is present from ground to almost 10 meter below the ground, followed by the rock. So this is a one part of this profile only I have shown before. This is the subsoil profile. This is the if you can see, this is the plan of the terminal. Here you can see the in red color and the blue color. You can see the borehole. This icon shows the boreholes. So this is the plan, and this is the longitudinal profile. So, by preparing a longitudinal profile like this, it gives an idea, the idea of the geology of the site or the subsoil conditions, which will help us further to derive the parameters, which is useful for the design. Point 035 G, which is used for the design. Now, geotechnical investigation. We will see in detail how what is geotechnical investigation, what they are doing in that. So, uh, there will be drilling, sampling, and collection of the disturbed and undisturbed soil and rock samples. Conducting field and laboratory test of the samples collected. So, coming to field investigation. In field investigation, the boreholes are advanced using rotary drilling machine, and the drilling was carried out on the overbed and cutting tools, and the wash boring process used to remove the cuttings from the bottom of the borehole. The disturbed samples were taken at the corresponding depths where SPTs are done, and undisturbed samples are conducted where quasi soils are available or where N values are less than or equal to 6. Now the standard penetration test that is done based on BS 1377. Since this is an international project, all the codes used or the design will be all based on Euro codes. Either the country's own codes or Euro codes we follow. And the disturbed samples of soil were collected both from SPT tube and cuttings collected from the washings. Triple tube core barrels were used for the drilling in hard rock, and the rock cores were evaluated at the site using visual observations and CR and RQD parameters, which we will discuss in detail later. Standard penetration test. I hope all of you will be knowing about the standard penetration test. So the number of blows of hammer required to drive each 150 mm will be counted. So each SPTN will be number of blows required for 300 mm penetration beyond a seating of 150 mm. If the SPTN value is exceeding 50, in that case it is considered as a refusal and the test will be discontinued. Now on the right side you can see the setup and the idea of SPT. So once the drilling is done to the desired depth, the drilling will be tool will be removed and the sampler will be placed inside the borehole. The standard split pun sampler is used. Outer diameter of the sampler is 50 mm. Weight of the drop hammer is 63.5 kg and freefall height is 760 mm. Now, field bore log. Bore log also most of the you people will be aware, I guess. It is a detailed record of the conditions and data gathered during the geotechnical exploration. This is created by recording the in situ ground conditions encountered in a borehole, and it is done by visually inspecting the samples brought to the surface. A bore log will be containing soil types, the water table, soil consistency, corrosive or non-corrosive, permeability. All the data will be available in the field bore log. Now, this is a typical field bore log. I thought it will be helpful for you to understand how it actually looks like. So, it will have depth, all the depths, the elevations, all the soil descriptions, SPTN values. For soil, it will be SPTN values. In case of rock, it will be CR and RQD. So, all the data will be available in the bore log. Now, laboratory investigation for soil samples. What are the tests available for soil? That are particle size distribution, specific gravity, then Atterberg limits, natural moisture content, pre-selling index, consolidation test results, triaxial, unconfined compression test, and chemical analysis of soil. Now, on rock samples, we have uniaxial compressive strength test, point load test, modulus of elasticity, porosity, specific gravity, and water absorption. This is a typical laboratory test result in which both soil and rock laboratory test results are available. So, in there is a grain size analysis, Atterberg limits for the clay soil and the consolidation and other triaxial test results for the clay soil if available. And in case of rock, we have UCS values and sometimes other parameters also will be available, depends on the projects. Now we have gone through the geotechnical investigation. Now, if we have the investigation report, as I told, we will prepare a geotechnical interpretative report, which is the main idea of the report is to come to that design parameters, to derive the design parameters. So, what are the design parameters? We have both soil and rock. So, what are the concerned design parameters for soil and rock? Soil have both corrosive and cautionless soils. For corrosive soils, SPTN, unit weight and untrained cohesion. For cautionless soils, SPTN, unit weight and angle of internal friction. In case of rock, it will be core recovery, then rock quality designation, RQD, unit weight and unconfined compressive strength, UCS. Now, how to derive this soil parameters? First of all, we have the SPT, so the correction factors for SPTN, then angle of internal friction, cohesion, then Poisson's ratio. We will go one by one. Correction factors for SPTN. This is as per JE Bowles. You can find the same in IS 1893 also. So we have two correction equations given. The N160 is for sands, mainly the penetration resistance corrected for both road energy and for overburden pressure also. This overburden pressure will be only conducted for sand. If it is clay, this overburden pressure correction is not required. So the N measured is the SPTN value measured at the site. Then CN will be the overburden pressure correction, which is used to calculate this equation is used. Then effective overburden pressure P naught. CE correction factor for energy, that is CE. CD will be correction factor for borehole diameter. This is correction factor for sampling method, and CR is the correction factor for the road length. Now the correction factors. What are the correction factors? Their values. Um, Everything is tabled here. You can find it in the textbook or the code that I have mentioned. Now the next one is angle of internal friction. So to derive an angle of internal friction, which is a cautionless soil property, N160 is used. And the values available from the graph will be restricted to 34 degrees for silty sands. This is based on the past experience and past projects, whatever in the same similar region. Based on that, we have come to that conclusion. For SPTN less than 10, it is difficult to find it from the graph. Hence, if lab data is available for the same, then that can be considered in the design. Now, next is cohesion. Cohesion, this untrained shear strength is derived based on the SPT, corrected SPT value. Here we will use N60. We don't need overburden pressure correction here. So as per CDR report 143, CU will be 5 times the N60. Whenever lab data are available, the same can be considered for the design. Now Poisson's ratio. So as per J. Bowles, the Poisson's ratio is tabled here, and uh, the values can be project specific. So in this case, we have gone with zero point 0.3 in case of sand and silty sand soil, and for clay soils it was 0.45. Now derivation of the rock parameters. The parameters are core recovery, rock quality designation, unconfined compressive strength, Poisson's ratio. This is CR and RQD. These are the indicators of the quality of rock, and foundation capacity is highly depend on these values, which are very important for the design. Now, what is core recovery? Core recovery, it is the percentage of the drilled rock that is recovered as a core in rock core drilling. It is calculated by dividing the length of the recovered core by the total length of the core. Then core recovery, it is also indication of the condition of the rock. Low core recovery indicates poor rock quality, while a consistent rock recovery of 100% indicates the good quality rock. Now rock quality designation. So RQD is the percentage of drill core pieces which are longer than 10 centimeter in length, and it is measured along the center line of the core. Then RQD is also it is used to assess the quality and integrity of the rock mass. RQD is a rough measure of degree of jointing and fracture in the rock mass. So if RQD is more than 75%, it is a high quality rock, and if it is less than 50%, it is a low quality rock generally. Now core box photos. So core box photos may contain soil and rock samples. Now we have only rock samples here. This core box photos, it will have the details of the project will be given somewhere near, and borehole number will be available. Core box number, intervals. If you can see here from the depths. So the intervals will be seen. The CRRQD values are noted down here, and the core box photos actually gives the idea of uh, the soils and the rock samples present, and the quality can be assessed from these photos. Unconfined compressive strength UCS. This is maximum stress that sample can withstand under a specified loading. In case of pile foundations, where very concentrated loads are applied at a point, this parameter gives helps to assess the quality of the rock. So this is the interpretation of the UCS values available from the all boreholes. So from here we can have an idea of what are the average values of UCS, minimum and maximum. So this will help us in finding the design values which can be used for the design. The Poisson's ratios for a rock. The mainly we have considered 0.25 as per the table. If you see, it is 0.1 to 0.4. It depends on the project. We go with the actual values based on the geology. Now, foundation design parameters. This is a typical example of design parameters based on the investigation data. So, in the geotechnical native report, finally we come to a conclusion of this design parameters, which will be further used in the design as I specified before. So here we have clay, sand, and the corresponding properties from what elevation it is available, what are the PTN values, what are the unit weights. For clay soils, it is CU. For sandy soils, it is angle of internal friction. So, and CRRQD values for the rock available, as I told, it is garnet, biotite igneous, which is available. What are the design uses? From the available uses values, we will come to a design UCS value. Now, what are the types of foundations available? As we know, there are two types, which is one is shallow and one is deep. Shallow means for building foundation that are transferring structural load to a very near which is very near to the surface. So load will be transferred to the nearest strata. The width of the entire foundation will be greater than its depth. That will be shallow foundations. Now deep foundations. Deep foundation that transfers load to the deeper depths from the surface, and one of pile is one of the deep foundation, and a pile is a vertical structural element of the deep foundation. It can be driven or drilled deep into the ground at building site. Now, how do we select a foundation? What are the things we need to keep in mind while selecting a foundation? So, the characteristics of the soil, presence of groundwater table, then magnitude of the imposed loads, project characteristics. Sometimes there will be employer requirements that we should go with this type of foundation, and the selection of the foundation should be not only merely based on the safety, but also it should be economical. Now, selection of foundation. Selection of foundation in this project, we mainly went with the pile foundation. So why didn't we go for shallow foundation? In the field SPT and values that are available are very less, and the soil is subjected to liquefaction, and subsoil strata present is not able to meet the requirements. That's why we went with a pile foundation. Now, since rock is with a good RQD, and the UCS values that are available are very good, that indicate high So the excavation will be done till the required depth and it will be concreted later along with the cage. Now, what are the challenges in installing a bored pile? The defects can occur at any point during the construction. It takes a skilled labor to install them properly, which drives up the overall price of the project. And the most common types of pile integrity issues that are coming are presence of voids and inconsistency in concrete mix and trapped groundwater or slurry and geometric errors. What are the advantages? uh, Excellent resistance against corrosion and strong winds. There is ability to withstand active tectonic forces. Can be installed in most any kind of weather conditions. Less disruptive to the surrounding ground and buildings. Offer good load bearing capacity and used to support large structures. Disadvantages. This is very more expensive than other foundation methods. Requires skilled operators, but and can be disruptive to the surrounding ground and buildings if it is not installed properly. That is why we need skilled laborers. And vertical pile capacity. Now we will dive into the pile capacity and pile capacity calculations, etc. So the pile capacity, it is the resistance of the soil to the loads, which is applied in the direction of vertical axis. And piles can gain this capacity through skin friction along the pile walls. This skin friction will act along the length of the pile and bearing pressure, which is on the pile end. So skin friction is caused by the relative movement of this pile and soil. So the interface between the pile and soil will develop skin friction. It will mobilize skin friction. Skin friction acts in the upward direction along the pile, and equal and opposite forces act on the surrounding soil. End bearing. The bottom end of the pile rests on a hard strata, stronger layer. The loads from the superstructure are directly transferred to the hard soil through the bearing action of the bottom tip of the pile. Now, we are in this presentation. We are discussing the pile design based on IRC code, then BS code, and ICE manual. So first of all, we'll go with the IRC 78. But this in this project we haven't considered IRC 78. The ultimate capacity of pile, which is socketed into the rock, is a um, will be obtained by ultimate end bearing and ultimate side socket shear. The allowable capacity of the pile is obtained by dividing it with the factor of safety. The ultimate end bearing is divided with a factor of 3, and ultimate side socket shear is divided with a factor of 6. Now, the ultimate end bearing and the ultimate side socket shear is calculated using this. Um KSP, it is an empirical coefficient. The values are ranging from zero point 0.3 to 1.2, and this is based on the QD divided by 2, this value. So for the corresponding location, we need to find with the CRRQD values. Now QC is the average and contained compressive strength of the rock below the base of the pile for twice the diameter or least the lateral dimension of the pile. Um, so that is end bearing. Now shear this side socket shear, that is CUS, the ultimate shear strength of rock along the socket length. This is calculated by 0.225 root QC, but restricted to the shear capacity of the concrete of the pile. For M35, it will be restricted to 3 MPa. And for other grades of concrete, a factor of root FCK by 35 might be applied. And AS is the surface area of the socket. So this gives the ultimate value, which will divided by the factor of safety will give you the allowable capacity of the pile. That is the safe capacity. Now pile design as per BS 8004 2015. The resistance of a pile foundation in rock depends on the roughness of the rock, in the roughness of that rock socket actually. The ultimate unit skin resistance is calculated by the equation given. QS is equal to K1 P reference and Q divided by P reference to the raise K2. Now ultimate unit base resistance is calculated by the equation given below. What are the K1, K2, K3, K4 parameters? They are the empirical coefficients that depend upon the rock or pile type. P reference is the atmospheric pressure, which is assumed as 100 kPa. Qu is the unconfined compressive strength of the rock. And this table gives the coefficient K1, K2, K3, K4. So based on this table, we have considered the value. Now, pile design as per ICE manual C54. The ultimate skin friction for piles socketed in rock are calculated based on the empirical equation given. It is empirical equation by Harworth and Kenny. QS is equal to zero point 0.2 root UCS, and ultimate end bearing resistance is equal to this is equal to UCS, which is available. Allowable capacity as per ICE manual is the ultimate bearing value will be divided by 3 and the ultimate skin resistance will be divided by 1.5. The factor of safeties. So as we just told now, for IC manual, for on shaft we are using 1.5, on base we are using 3, usually with working pile load test. In case of BS 8004, the partial resistance of all limits are based on the BS EN 1997. This is the Euro code and UK national annex. So this table gives the partial resistance factors for BS 8004. So in this case, these are the different kinds of loadings. So ULS STR GO DA1 C2, that was the critical case. So the factors considered are 1.7 and 1.4. So the base resistance factor, these factors are multiplied by a model factor. So this 1.4 is available as per the Euro code. It is multiplied and the factor of safety is obtained like this. Now we will go with the typical pile capacity calculation. Is the screen visible? Is the screen visible?
Yes, yes, it's visible. It's
Ah,
visible. It's visible.
yeah, okay, okay. So this is a typical pile capacity calculation sheet. It will have all the data of the location, the diameter of the pile, and required pile capacity, what is the existing ground level, what is the pile cutoff level, and the design parameters for that corresponding location. So first of all, we will go with pile capacity as per ICE manual. So this side socket shear, as I have told before, it is calculated using this equation. The corresponding values are calculated based on that equations given, and the available values are divided with the factor of safeties, and ultimate end bearing resistance is equal to UCS. That is divided with the factor of safety to obtain the allowable capacity of the pile. Now the second method is BS8004. This finding out the required socket length is the trial and error process. You need to play with the socket lengths to come to a conclusion, which is what we are going to recommend. So for both methods, I have what I have done is for both methods I have found out a value, like same value I used to, and whichever is giving minimum value that I have considered. So BS8004, the skin friction resistance is calculated using this equation, and the all the factors and everything we have used is mentioned here. Similarly, for the this is the table of partial resistance factors that I have mentioned before, and this is the unit end bearing equation, which this K3, K4 parameters are used as mentioned before, and finally from the ultimate values, by dividing with the factor of safety, we will come to a allowable safe pile capacity. And finally, the allowable safe pile capacity will be minimum of the two available. And so from that, we will recommend pile capacity based on the requirement. So and the socket length and so pile and bearing strata, everything will be mentioned. Now coming back to the presentation. Uh, Now, lateral pile capacity. Now, till now, we have discussed about the vertical pile capacity. Similarly, there are codes and empirical equations and everything for the lateral pile capacity also. But currently in industries, people are using software. So even for vertical pile capacity also, there are softwares. So different consultancies, they have different approach towards the calculations. So lateral pile capacity is mainly calculated using LPIL. It is a special purpose program based on the rational procedures for analyzing the pile under lateral loading. This is using PY method. PY curves. They are the tool used for in the geotechnical engineering to estimate how soil resists the lateral forces or lateral load on the structure. Then this method assumes that the soil resistance is a nonlinear function of the pile deflection. Soil response over the length of the pile. So in some cases, most of the cases, vertical pile capacity will be governing, but some of the cases, the lateral pile capacity will be governing. So in the software, we will have a rotation check and the deflection, bending moment, shear force, all these values we will check whether they are within the limits. If they are not, then we have to increase the socket length. So, which is governing based on that, we provide the recommendation. Now, coming to the conclusions. So the pile foundation is chosen when topsoil has poor bearing capacity. Piles are convenient method of foundation for works like works or over water, such as jetties, then bridge piers, etc. Then the design of pile foundation involves providing adequate pile type, size, depth, and number to support the superstructure load without excessive settlement and bearing capacity failure. And pile load carrying capacity depends on the various factors like soil properties and pile installation method. Uh, that's it. That's the conclusion. Yeah. Thank you. That's all.
Dear participants, the forum is open for discussion. If there is any queries, you can ask.
Actually, at the end of the presentation, I have my given my Gmail. If anyone have any clarifications you need, you can contact me over here.
Well, I think there is no discussion from the participant side, I think. And if
Oh,
that is so, anyways, like, thank you, Gayatri, for such a short and sweet presentation. Thank you so much.
yeah, thank you.
Th- Thank you, participants, for the patient listening. So tomorrow we'll meet up for the last day for this of the 6 day FDP. So thank you once again. Thank
Yeah,
you, Gayatri. Thank
yeah.
you.
Thank you for
Thank you, everybody.
inviting me. Yeah.